Hi everyone, this is the 5th lesson video for Chapter 8, and this is our course content for this video. We will talk about the concept of arrays, and we'll focus on one-dimensional arrays and two-dimensional arrays. Arrays are used to store multiple data items in a uniformly accessible manner. All the data items use the same identifier, and each data item can be accessed separately by the use of an index. In this way, lists of items can be stored, searched, and put into an order. For example, a list of names can be ordered alphabetically, or a list of temperature can be searched to find a particular values. The first element of an array can have an index of 0 or 1. However, most programming languages automatically set the first index of an array to 0, and Python does the same. In Python, this is called a list, which is the same as an array. Array can be one-dimensional or multi-dimensional. Only one-dimensional and two-dimensional arrays will be covered in the course here. First, we will introduce one-dimensional arrays. A one-dimensional array can be referred to as a list. Here is an example of a list with 9 elements in it where the first element has an index of 0. When a one-dimensional array is declared in Python, it needs the name of the array and the value at its index position. Suppose we declare the value of the one-dimensional array mylist to be list. You can see the diagram of my list below. The first position has an index of 0 and a value of 27, while the last position has an index of 8 and a value of 55. Next, we will use program example to introduce the commonly used usage of one-dimensional arrays. First, as mentioned earlier, declare a one-dimensional array, mylist, and give it 9 values. Then we can use len mylist to get the size of the array, mylist. If you want to specify the value of a certain index position, you can use mylist index. For example, to specify the 0 index position of the output mylist, write mylist 0. To specify the last index position of the output mylist, write mylist -1. -1 means the last positions. What about mylist -2? -2 means it is the second to last position. Suppose you want to intercept a certain array. For example, from the 0 index to the second index, you can use array 0 to 3. Here, 4 in 3 for the second number to indicate that the third index position is not included. The first number can also be omitted here, because omitting the first number means starting from the 0th index position. On the contrary, if the second number is omitted, it will be included until the last index positions. If you want to change the value in the array, you can specify the index position to be changed. For example, write mylist 0 equals 13. When you print mylist, you can see that the value of the 0 index position becomes 13. You can also change multiple values at one time. For example, write mylist 1 to 3 equal 20 and 14. Print mylist, and you can see that the values of the first index position and the second index position become 20 and 14. If you want to add an element of 16 to the last position of the array, you can use mylist append 16, and you will see that the 16 is 8 to the end of my list. But if you want to specify where the new element is, you can use mylist insert 0 and 18, which means that 18 is inserted at the 0 index position. You can see that 18 is inserted at the 0 index position of my list. The original values has all moved back one space. After talking about how to add elements in the array, we will introduce how to delete elements in the array. First, if we know the value of the element we want to delete, we can use remove. For example, if we want to delete the element with the value 16 in my list, write my list remove 16, and we can delete the element with the value 16 in my list. What if you don't know the value? You can use pop index value to delete. For example, if you want to delete the first index position, write my list pop 1. The value of the first index position of my list will be deleted. If you want to delete the value at the last position of my list, you don't need to include any value in pop. Just write my list pop, and the value at the last positions of my list can be deleted. If you want to check whether 14 exists in my list, you can use syntax such as 14 in my list, which will return a Boolean value. Taking this as an example, it will return true. If you change it to 19 in my list, it will return false. It can also be rewritten as 19 not in my list, and true will be returned. If you know that the value must exist in the array but do not know the index position, you can use index to find the index position. For example, if you want to find the index position of 42 in my list, write my list index 42, and 3 will be returned, indicating that it is at the third index position. At the end of the one-dimensional array, we will introduce how to use a for loop to print out all the elements in the array. You can use for I in range len my list, which means that the range of I will be from 0 to the length of my list, inclusive. Print my list I, repeating I equals 0 to I equal len my list minus 1. Then you can see all the elements in my list. There is another way of writing for element in my list, which use the variable element to access the element in my list until end of my list. So elements can be used directly to represent the value in my list. Print element. You can see that this method prints the same as the method before. The next session will be introduced two-dimensional arrays. Suppose there is a 3x4 two-dimensional array in my table. There are 3 rows and 4 columns, and the index position of the first element is 0, 0, and the index position of the next element is 2, 3. Next, we will also use program examples to introduce the usage of two-dimensional arrays. First, declare a two-dimensional array my table. If you want to get the number of rows in the two-dimensional array, you can use len my table and get 3. However, there is no requirement in Python that the number of elements in each row must be the same. So, if you want to get the number of elements in each row, you need to use the for loop to get the number of elements in each row of my table. In this example, each row has the same number of elements, which is 4. If you want to specify a specific index position, you can also use my table 0, 0 to specify the first element. My table 0, 3 represents the elements in the third column of the 0 row. You can also specify an entire row of elements. For example, my table 1 represents all elements in the first row. If you want to change the value of the two-dimensional array element, you can use my table 0, 1 equals 13 to change the value of position 0, 1 to 13. You can also use my table 0 equals 13, 20, and 10 to change all elements in the 0 row. So, how to add elements to a two-dimensional array? You can use a pen and insert just that one-dimensional arrays, but it should be noted that the new elements need to be in the form of one-dimensional arrays. For example, my table append 16 and 13 means adding a new row 16 and 13 at the end of my table, and my table insert 0 and 18 and 0 means adding a new row 18 and 0 at the form of my table. Next is the deletion method. Remove and pop can be used here like a one-dimensional array, but just like the addition of a two-dimensional array. The one-dimensional array must be used as the unit when deleting. For example, my table remove 18 and 0 will delete the row elements 18 and 0 in my table. My table pop 0 will delete the 0 row element of my table. Finally, how to use a for loop to print out all elements in my table. As mentioned earlier, then my table represents the number of rows in my table. So we can write for I in range, then my table in the first level loop to indicate that we want to repeat I from 0 to the number of rows in my table, inclusive. And writing for j in range, then my table I in the second level loop means that every time my table I will get the elements inside one by one. Another way to write it is that the first level loop use the variable row to represent each row element of my table, and the second level loop use the variable element to represent each element of row. It can be seen that the results obtained by two methods are the same. There is a practice at the end of this video. Grade calculation. Write and run a short program. Suppose there are 3 students whose scores are as follows. We need to calculate the total score and average score of the 3 students respectively. First, declare a two-dimensional array variable grades to store the grades of 3 students. Then declare 2 empty array sum list and average list. Then use 2 layers of loop to calculate the total score and average of the 3 students. The first loop is to calculate the total score of 3 students separately. So a variable student is used to store the score list of each student. And the variable sum grade with the value of 0 is declared to store the student's total score, which will be declared on the first loop. The purpose of this is to return to 0 before calculating the total score of a new student each time. The second loop uses a variable score to store each score of a student. Each score of the student is accumulated in the second loop. After accumulation is complete, append it to sum list, and after calculating the average, append it to average list. Finally, print sum list and average list. That's done. We have finished the concept of arrays. Next, we will talk about file handling, including opening, closing, and using a file for reading and writing. See you in the next video.